Welcome back, y'all. In this video, I'm going to make diethyl succinate by doing a Fischer-Speier esterification, also known as the Fischer esterification, with succinic acid and ethanol. I need diethyl succinate as a precursor to a precursor that y'all will see in future videos. As I'm writing the script for this video, I've already used most of the ester I end up with in another reaction, so there won't be much time between this video and that one. I won't go into the Fischer esterification too much since there are a lot of other videos about it on YouTube. It was discovered in 1895 by Emil Fischer and Arthur Speier, and yes, that's the same Fischer that developed Fischer projections and did a whole bunch of other good chemistry stuff. The basic principle is you mix a carboxylic acid, an alcohol, a strong acid catalyst, sometimes a solvent, and reflux it. A large excess of the alcohol can be used to serve as the solvent instead, depending on a few factors, but I didn't do that because toluene is cheaper than alcohol, and water is harder to remove from just ethanol. I don't think solvents were initially used, like toluene in mine, in the original paper. I think it was just alcohol, acid, and acid catalyst, but I'll look into it and then add text on the screen. Water is formed in the reaction, and because almost every step in this involves equilibria, the water that's formed will cause the reverse reaction to occur, which we don't want. To favor ester formation, water needs to be constantly removed, which can be achieved by using an excess of sulfuric acid as the acid catalyst, or by including an addition funnel with a drying agent in the setup, often molecular sieves, or by including a Dean-Stark apparatus in the setup. I'll be using both a Dean-Stark apparatus and a dehydrating agent. The acid catalyst I'll be using is para-toluene sulfonic acid, also known as tosylic acid, and toluene will be the solvent. I couldn't find a specific procedure that uses all the reagents I have, so I combined two. One that uses the same acid, alcohol, and solvent, except with sulfuric acid as the catalyst, and another that uses a different acid and alcohol, but the same solvent and catalyst. Most people familiar with chemistry will know what an azeotrope is, and some common ones are between nitric acid and water, sulfuric acid and water, and ethanol and water. These are binary azeotropes with two components, but there are also azeotropes with more than two components. Toluene, water, and ethanol form what's known as a ternary azeotrope with three components, and this facilitates the removal of water during the reaction. When the Dean-Stark trap fills, I'll empty it into a 100 milliliter round bottom flask filled with a bunch of potassium carbonate to dry it, and once the RBF is full, it requires about 3 traps full worth, I'll filter the dried ethanol toluene mixture through cotton, then return it to the reaction flask through the condenser. I'll continue doing this until the liquid collecting in the trap stops being cloudy, then do it twice more for good measure, and then cut the heat and move on to the workup. All the reagents used were bought and used as is, other than the tosylic acid, which I made myself. A 100% excess of ethanol is used because, as I mentioned earlier, this reaction is full of equilibria, and an excess of ethanol will further favor formation of the diester. The tosylic acid I made is the monohydrate, and the water complexed with it will be removed during the reaction, just like the water produced from the esterification. It's a bit clumpy because it's damp with a little toluene, so I used 3.5 grams to be safe. It probably didn't make a difference since it's catalytic in effect, but oh well. A precise 400 milliliters of toluene isn't necessary, so I measured it approximately with a beaker. Here's the setup. Here it is refluxing. The succinic acid dissolves after a few minutes of it refluxing. You can see the Schlieren lines because the condensate mixing with what's already in the trap isn't homogeneous. And then here's the 100 milliliter RBF with potassium carbonate. I didn't measure this out, I'm just going to be winging it. You know the potassium carbonate is absorbing water when it clumps together, and when it stops clumping together, it's no longer absorbing water, or it no longer has any water to absorb. Afterwards, I'm just adding it back in through the condenser, right here, with a very big pipette. I ended up doing it 7 times, that is, filling the round bottom flask and returning it to the flask. And after that, I moved on to fractionally distill off the ethanol and the toluene. Once the boiling point reached about 110, 115 degrees, I want to say, I cut the heat, waited for it to cool down, and then transferred it to a smaller flask just because it would be a better recovery. And I washed out the 1 liter beaker or flask with some of the distillate. I didn't try and fractionally separate the toluene and the ethanol because it didn't really matter for me. I actually am gonna redistill what I just received in the 100 milliliter round bottom flask, and that really helps with the yield. The literature boiling point of diethyl succinate is, I want to say, 218 degrees Celsius. Here is when I switch out the receiver for this redistillation. There are Schlieren lines, meaning the distillate isn't completely pure diethyl succinate, but it doesn't need to be analytically pure. And here's what I ended up with. It is 159.2 grams of diethyl succinate of 99+% purity-ish, which is a 91.39% yield. I am very happy with this yield. I didn't actually expect it to be this high. I expected it to be somewhere in the 80%, maybe mid to lower 80%, but it worked really well. I don't know if I would even do it differently if I did it again. It just went super smoothly. I guess when I did the distillation, I could have just switched out the receiver earlier and saved me from having to redistill, but it's not that big of a deal. Thank you for watching. If you enjoyed this video, like, comment, and or subscribe. I really appreciate it. It helps me out, and I will see you in the next video.